In this video, we're going to discuss this P3 paper of a practice paper that you need to go through as you are preparing for your May June exam of 2024. We are going to cover most of the topics you've gone through and that you expect to have covered before you sit for the exam. So, in the first topic, we are having modulus functions and how we are going to see how you are supposed to approach this. We are told solve the inequality whereby you are given 2 modulus of 3x minus 1 is less than x plus 1 modulus. And in order to approach this question, remember, you are supposed to, there are different approaches you can be able to use. For instance, you can be able to, you can ignore one of the modulus and then use the positive and negative sign. But here, I want us to square both sides so that we can get rid of the modulus function. So we're going to square both sides, and remember, when you are squaring both sides, even the 2 that is there is going to be affected by the square that we're talking about. So if we square this, we get 4, and then we expand everything that we have on the right hand side and the left hand side. Remember, when you expand 3x minus 1 squared, you are going to get 9x squared minus 6x plus 1. And when you square x plus 1, we're going to get x squared plus 2x plus 1. So which means that we are going to put the like terms together and also take note of the sign that we have there. Is the inequality less than 0. So we are going to ignore the inequality sign, which is less than 0. Then we treat that sign as an equal sign so that we can be able to get the critical points for this quadratic curve that we have here. So which means that solving this quadratic equation, we are going to, you can use different method of solving because this video is not based on how to solve a quadratic equation. I'm going to just to give you the answers. For x is actually 1 over 7, and the second value of x is 3 over 5. So which means that if you draw this graph, remember it's having a positive x squared coefficient, which means this graph is going to open upwards. So we are having this solution and we're having this solution. So how do you choose which is the solution for this inequality? Remember, the quadratic we are having is 35x squared minus 26x plus 3 is less than 0. It means we need the lower part. We need the lower part of the quadratic. So we are going to say our solution is going to lie between x at the point where x is greater than 1 over 7 but less than 3 over 5. There's another way you can be able to approach this. You can draw this and represent all this in a number line. If you are having a challenge on how to identify which is the best solution to this, you can draw a number line like that. So that you draw where you have 1 over 7, you also represent on a number line where you have 3 over 5. Then you select different regions. You see I've selected below 1 over 7 we have 0. Between 1 over 7 and 3 over 5 we have 0.5, and after 3 over 5 we have a 0.1. So meaning we are going to try these values using the original inequality that we were given, 3x minus 1 less than the modulus of x plus 1. So you are going to put 0 in that. You check whether is it going to satisfy the inequality. If not, you try 0.5. Is it going to satisfy that inequality? And also you try 1. Now, if 0 satisfy the inequality, if it satisfies the inequality, you are going to say the solution is x is less than 1 over 7. But if 0.5 satisfy this inequality, when you put those values inside there, you're going to say the solution is x is greater than 1 over 7 but less than 3 over 5. Also, if 1 satisfies, you are going to say the solution is 3 over 5 is greater than, rather x is greater than 3 over 5. So those are different ways you can use in order to choose the solution, because most of the students find a challenge on stating the solution after even working out up to that particular point. So we need to move to the next part. If you are new to Proflan YouTube channel, consider subscribing so that in time we're going to upload further tutorials, you'll be notified. Then we need to move to the next question. Need to move to the next question. Yeah, so let me just write the solution for this question, because I've tried and I've observed that if I substitute 0.5 into the inequality, the only point that is going to satisfy this is 0.5. So since 0.5 is between 1 over 7 and 3 over 5, I'm going to say therefore the solution is x is greater than 1 over 7 but less than 3 over 5. All right. Okay, so that's it. We move to the next question. The next question that you'll or the next topic that you expect to be tested in your May June exam in your coming P3 paper is a question on to represent complex locus or loci in an Argand diagram, and you are told on a sketch of an Argand diagram, show the region that represents complex number z, such to find the inequality z minus 1 minus I is less than or equal to 3. Also, we are told the arc z plus 2I is greater than or equal to 1 over 4 pi, less than 1 over 2 pi. And we also have imaginal z is less than or equal to 2. Now, this is a very interesting question, because it cannot miss. Some of this question can never miss. It's only that a question can be asked differently, but as much you are preparing for your exam, the best thing you need to do, know how to answer these questions. So the first thing that we are going to do, we are going to draw an Argand diagram. In this case, this is the imaginary z-axis, and then we have the real z-axis. The first um, inequality that we are given here, z minus I. Remember, we are going to write it in standard form. In standard form, this is going to be z minus into bracket 1 plus I. Remember, we were given minus 1 minus. So if you factor negative out, because this is the standard way, this constant distance locus, this is actually a locus that represents a circle. And the center of this circle is actually 1 and positive I. So, and the radius of this circle is going to be 3. Since the inequality is less than or equal, it means the locus is representing the region inside the circle. So we are going to say this is a circle, center 1I and radius 3. So we're going to locate the center at this particular point, and then we shall draw our circle at that given point. Let me move it. So yeah, so our circle is represented there, well represented. So which means this is the locus is the region inside the circle. Now, the other one is the angle locus, and let me just and this is the center. All right, we are done with that. Let's move to constant angle. So this is arc z. Also, we're going to represent it in the standard form. This is going to be z minus 2I, because all these locus are usually represented by z minus whatever you have. So you see, that's why I've introduced the negative, so that if I multiply negative 1 times negative, negative times a negative is going to give me the positive that was originally there. So meaning that this half line is going to be that. Yeah. So I'm going to locate the point where that half line is. That's going to be, the point is 0 negative 2I, 0 negative 2I. This is the point, and then I'll draw an horizontal line like that, and so the angle is going to sweep upwards what a quarter pi. So this angle is going to sweep from the horizontal line upwards in the anti-clockwise direction. This is going to be our a quarter pi one, and the vertical line is going to be a half pi. A half pi is 90. So, and a quarter pi is 45 degrees. So this is going to be this the one that is for a quarter pi, and the other one here that is along the vertical axis is actually going to be 90. So I've represented the one that I've used the two red lines represent the arg z minus 2I is greater than or equal to a quarter, but less than or equal to a half pi. So we have also imaginary z is less than 2. So we go on the on the imaginary axis, we identify where we have 2, we draw it like that, and this is going to be below that. So the region representing this locus that we're given here is this region I've labeled with those green colors. All right, so that's what you're expected to do. And if you are finding value, consider subscribing, and also you can leave a comment down below if the video was helpful. We're told to expand cube root of 1 plus 6x in ascending powers of x up to including the term x cubed, simplifying the coefficient. So in this particular case, we are going to use binomial expansion, and in that way, we are going to use the formula that we learned, and the formula states 1 plus nx plus n into n minus 1 over 2 factorial than x, and then we're going to move to n into n minus 2 over 3 factorial, then x is going to be squared in this case, and then we are also having the part where we're having 3 factorial, we're going to cube x. But remember, we are going to do this question up to x cubed. That's why I've stopped there. Now, in this case, remember our x is 6x, so which means that we are going to substitute 6x into at the point where we have x in the process of solving this, and our n is 1 over 3 is a third is the same as the cube root. So anywhere we have n, we're going to substitute 1 over 3, and where we have x, we're going to substitute 6x. And if we will substitute it, this is exactly what we are going to get. Let me just move a little bit so that we can be able to have some space. And this is going to be 1 over 3 minus 2, and this is 6x cubed. 6x cubed. In that case, this is actually 6x cubed here, not squared. So if you simplify that, you are going to get our final answer as 1 plus 2x minus 4x squared plus 4t over 3x cubed as our final answer. Now, another topic that you can also be expecting is a topic to do with trigonometric identities, trigonometric proofs, and also solving trigonometric functions and equations. So, which means that you need to prepare well in that kind of equation. We are told here that by first expressing the equation tan theta plus 45 equals to 2 cot 2 theta as a quadratic equation in terms of tan, solve the equation for theta greater than 0 but less than 90 degrees. So, which means that in this question, first we need to understand how to express the double or the compound angle of tangent or tan, and also double angle of tan. So We are going to expand this in the sense that tan theta is going to be expressed as follows. So we are going to have tan theta into tan theta plus 45 over 1 minus tan theta tan 45. Actually, I'm expressing the tan theta plus 45 when you are given the compound angles, how it's supposed to be. And this is actually going to be 2 over tan 2 theta. And then we are going also to see what tan 2 theta is equivalent to. But you need to remember that tan 45 is equal to 1. So we need to simplify that further. So anywhere you have tan 45, you are going to replace that with 1 so that we can be able to have this a little bit simplified in the process of arriving to the quadratic equation that they want us to have. Remember, tan 2 theta is actually 2 tan theta over 1 minus tan square theta. So the next thing, once we get this, we are going to multiply both sides. Okay, on the, you can see on the right hand side, we are having 2 over 2 tan theta over 1 minus tan square theta. So which means on the right hand side, I can multiply at the numerator and denominator by 1 minus tan square theta so that I can be able to get rid of that fraction that we have here. So we are going to cancel 1 minus tan square theta and 1 minus tan square theta so that we are going to remain with 2 over 2 tan theta, so that I can also multiply all through by 2 tan theta so that we are going to get rid of that fraction again. Yes, this part and this part will cancel out. And expanding this, I'm going to have 2 tan square theta plus, no, 2 tan cubed theta minus plus 2 tan squared theta. And on the other side, I'm having, yeah, 1 minus tan theta is there. And the other side we shall have 2 minus 2 tan squared theta. Then I'm going to multiply again by this fraction part, which is 1 minus tan theta, both sides, so that I can also get rid of that particular fraction. This will cancel out, and I end up remaining with 2 tan cubed theta plus 2 tan squared theta, which is going to be equal to that. If I'm going to expand this, what am I going to get? I'm going to get 2 minus 2 tan theta minus 2 tan squared theta. And if I multiply negative 2 tan squared theta times negative tan theta, I'm going to end up having positive 2 tan cubed theta. So which means I'm going to cancel the first and the last terms because both of those are like terms. Then we're going to remain with, I'll take 2 tan squared theta on the other side. So that's going to be 4. Actually, this one is going to be 4 tan squared theta. We are going to have this 2 tan theta going this side, and then we shall have minus 2 equals to 0. Now you can see we have a quadratic equation that need to be solved in order to find the solution of that. So before that, we need to divide by 2 all through to simplify this quadratic equation in terms of tan. Now, letting tan theta to be equal to x, we're going to form our quadratic equation. Because endpoint we have tan theta, we're going to replace with x. So the first term will be 2x squared plus x minus 1 equals to 0. Then we're going to solve this quadratic equation so that we can be able to get the solution. So solving this, we're going to get x equals to a half, or x equals to minus 1. So which means that having the value of x, we can now replace with the tan theta that we had said, so that we can be able to solve this trigonometric. So solving tan theta equals to a half, we're going to get 26.6 degrees. And if you solve tan theta equals to -1, we are going to get -45. And you can see this one is out of the range since we were given theta should be greater than 0 but less than 90. So the solution that we're going to take is 26.6 degrees. The next question is a question here whereby you are told the diagram shows a curve 2 minus x e to negative a half x and its minimum point m. Find the exact coordinate of m. So in order to find the exact coordinate, we are going to actually differentiate y, the curve that we're given, and equate to 0. But since this is two functions which are multiplied together, we are going to use product rule. And remember, product rule states if you have two factors multiplied together to find d u v dx, you are going to say is u dv dx plus v du dx. And I'm going to let the whole of this function 2 minus x to be equal to u and e to negative a half x to be our v. So once you do that, in order to work it out, remember first we are going to find u dv dx. So we shall write the u here, which is 2 minus x. If you differentiate e to negative a half x is going to be negative a half because you differentiate the top and you multiply it with the exponent. And we are going to have negative a half e to negative a half x, and then plus that if you differentiate, because we are finding du dx, if you differentiate du dx, this function, if you differentiate it, you are going to get -1. So that -1 times the function v, you can see we are going to have minus e to negative a half x. If you factor out e to negative half x, this is what you're going to remain with, because at the minimum point dy dx equals to 0, we can form an equation which we are going to solve. So from this particular point, we can say negative, because I took actually the negative, this negative out also, negative e to a half negative a half x equals to 0. Because the whole of this function equals to 0, we can say this part equals to 0, all this part is equals to 0. So but we know that for en exponential function, it can never be equal to 0. That's why I said at this point that has no solution. So the bit that we are remaining with that should be equal to 0 is this part of the equation. And we're going to say a half into 2 minus x plus 1 is equals to 0. I multiplied by 2 all through, and I took x on the other side. I brought -2 on this side, and I solved to get my x equals to 4. Then the y coordinate, to get the y coordinate, you need to substitute x equals to 4 to the original equation that we were given at this given point. And I got my y coordinate to be -2 over, that's -2 e to -2, which can be also written in this form. So m is going to be 4 -2 over e is to 2. So that is how you are supposed to work out that bit. But for question number 5b, we are supposed to find the area of the shaded region, area of this shaded region here. But for you to find the area of the shaded region first, you need to know what is the limits you are going to use. The limits of integration is from 0 all the way to this point. So in order to solve this point, we are going to equate this equation that we have here to be equal to 0. So then if you equate it to 0, remember e to negative a half x equals to 0 has no solution. So the b that is going to give us a solution is this. And you can see if you take x on this side, we're going to have 2 as the limit of our integration. So the area of the shaded part is usually given by integrating within the given region of y dx. And this, because we're integrating this, we're going to integrate using by parts. because these are two functions multiplied together. So we have u and we have dv, and I've used lippets which enable us to decide which one is our u. If you see a natural log, that would be u. If it happens that in your function you are going to see first inverse trigonometric, is going to be u. If you see a polynomial, because you see in this part we have exponent and a polynomial. This is 2 minus x is a polynomial, but exponent is after a polynomial. You see, this is a p, which is polynomial, this is exponent. So polynomial comes first, so which means not comes first in this, it appears in this function. So it's going to be our u, dv is going to be this. So we're going to use a table and say u equals to 2 minus x, the one that we said. Then dv is going to be e is to negative 1 over 2 x. Then in order to get du, we are going to differentiate this, which becomes negative 1 dx. And in order to get v, we're going to integrate this. Integrating an exponent, you differentiate the top and divide it by the original expression. So if you do that, you are going to get negative 2e to negative 1 over 2x. Then according to integration by parts, if you multiply this expression, this is addition. So this why you see multiplied 2 minus x times negative 2e to negative x. Then subtract. When you multiply diagonally like this, you are going to subtract, and this is the bit that we are having. And now we are going to have negative 2 into 2 minus x e to negative 1 over 2x minus 2. I've taken these 2 out of the integral sign, and I'm remaining with e to negative 1 over 2x dx. So you can see the bit that we have here is actually simplified. So we can again integrate that so that we can be able to have the final integration shown there. So this reduces to this, and the limit of integration is from 0 to 2. Substituting the values, you realize that we are going to have our final answer as 4 over e, because anytime you have negative 1 over 2 times 0, that's going to be e is to 0, and e is to 0 is 1. That's why we are going to have like these false here. The next question, we are told that a polynomial 2x cubed minus x squared plus a, where a is a constant, is denoted by px. And it's given that 2x plus 3 is a factor of px. We're supposed to find the value of a. Now, we are going to use factor theorem. In this case, remember, since we are told that 2x plus 3 is a factor, we can be able to say that we can say 2x, since it's a factor, we can say this 2x plus 3 is equals to 0 and find the value of x. So x equals to negative 3 over 2 is actually a root. So meaning if we substitute this into the function, we are going to get 0. Since it's a root, if you put it in the function given, the answer should be 0. So we are going to substitute there. We are going to say this is 2 into negative 3 over 2 cubed minus negative 3 over 2 squared plus a is equal to 0. So we are going to solve the simultaneous, actually this equation, in order to get the value of a. So simplifying this further, we're going to get that our a is going to be 27 over 4 plus 9 over 4, which is going to translate to 9. So a in this case is 9. So let's see the next question that you were asked at this point. So you can see Now that we have the value of A, when A has the value solved in the inequality above, in the section part, when A has this value and the value we're talking about is 9, solve the inequality Px less than 0. So this is the second part we are doing inequalities, but this is now in another level. So we are going to factorize this so that we can be able to check the critical point of this cubic inequality, and then graph it so that we can be able to take the solution of that. But remember, we had gotten the factor. We were told that there was a factor there. Yeah, we were told that this is a factor. Then we are going to say, if we take this factor divided by the cubic function, we can be able to get another factor. Yeah, so the first part here, we are going to ask us, which number do we need to multiply by 2x plus 3 in order to get, okay, which number do we need to multiply by 2x to get 2x cubed? That number is x squared. So if you multiply this x squared by 2x, we're going to get 2x cubed plus 3x squared. Then we're going to subtract the two parts. This part is going to be 0, and then minus x squared minus 3x squared, we're going to get negative 4x squared. And then we are going to pull this down. So the next term that we're going to take actually is negative 2x. Negative 2x times 2x plus 3 is going to give us negative 4x squared. Negative 2x times 3 is going to give us negative 6x. So we again subtract this. We are going to get this part going to 0, and this becomes a 6, and we pull 9 down. We are going to have 6x plus 9. So which value do we need to multiply by 2x plus 3 in order to get 6x plus 9? That number is 3. So which means that if we multiply, we're going to get 6x plus 9, and then we subtract, we get 0. So x squared minus 2x plus 3 equals to 0 has no real roots. If you try to solve this, it has no real roots. So meaning that the only point where this cubic function is going to cut the x-axis is going to be a point where we have x equals to negative 3 over 2. So since we need in our inequality, we need the part that is below the y-axis, which is less than 0, we are going to say the solution is going to be x is less than or equal to negative 3 over 2. So all the values to the left are going to satisfy this inequality. Yeah, so this is basically what you are supposed to do in this particular section. I've tried to plot it in decimals in order to see how the graph behaves. Let's see how the graph looks like. You can see now it has only one x-intercept, and this is actually a turning point. It has a point of inflection at the top there. So you can appreciate the fact that this is only cutting on the axis at one specific point, this particular point here. Yeah, so that's why we say the solution is going to be one value at that particular point. All right, so this can make us to move to the next section of this paper. The next question is where you are supposed to do differential equations, and we are supposed to solve this differential equation. X plus 1 into 3x plus 1 dy dx equals to y. We are going to separate the variables so that we have 1 over y on this side and 1 over x plus 1, 3x plus 1 on the other side. So, but remember this part, we are going to now integrate the left hand side and the right hand side, but we cannot be able to integrate this. There's no technique we can be able to use in order to integrate this unless we express this part as partial fractions first. So expressing this as a partial fraction, we are going to say 1 over x plus 1 into 3x plus 1 is equivalent to 1 over this part and 1 over this. And then we can multiply all two by the, or what is in the denominator of the left hand side. We are going to end up having 1 is equivalent to a into 3x plus 1, b into x plus 1. So meaning that we can now let x be equal to -1 so that we can be able to find the constant a. If we let x equals to -1, the whole of this part will run to 0, and we are going to have our a equals to -1/2. But if we let x to be equal to -1/3, the whole of this part is going to run to 0 so that we can be able to find our b, which is going to be 3/2. Now our partial fraction is -1/2 x plus 1, 3/2, 3x plus 1. So our differential equation that we were having at the original point here now can be expressed in this format. So at this given point, we can be able to integrate both sides. Remember, if you are integrating 1 over y, it becomes ln of y. If you are integrating 1 over x plus 1, it becomes actually -1/2, yeah, ln of x plus 1. Integrating this term, remember this, there is a coefficient of x at this point, so we are going to differentiate this, and that becomes 3, and divide it to the integral that we are going to get. So it is going to be ln of 3x plus 2 divide by this number 3 that we are having here times the 2/3, the 3/2 that we were having originally, and our integral becomes now 1 ln of y equals to 1/2 ln of 3x plus 1 minus ln of 1/2 ln of x plus 1. Actually, this as becomes after here because this was a negative, so that's why we are having it in front of this negative value. So we end up simplifying this, because if we are having ln over 3x plus and minus this, this is the same as when you're having two natural logs subtracted, you can divide them in individual numbers. For instance, this is going to be 3x plus 1 over x plus 1, and then we say plus c. But since we were given the initial conditions, y equals to 1 when x equals to 1, we can be able to use them in order to find the value of c. So ln of 1 is actually 0. And if we substitute 1, x equals to 1 into this, it is going to be 4/2. And this is going to be now 1/2 ln of 2 plus c. And then this is ln of 1 is actually 0, and then we are going to get a value of c to be equal to -1/2 ln of 2 in that case. So our equation now becomes ln of y equals to 1/2 ln 3x plus 1 over x plus 1 minus 1/2 ln of 2. So this can actually be simplified because we are having this half both sides. We can just multiply the denominator by 2 because this is subtraction, so it's going to be divided by the original part. So basically this is what we're going to have. And in order to solve for y, we are going to, when you have a number behind the natural log, it's going to be the power of whatever you have here. So since this is half, is going to be the square root. And then since we are having ln, they can cancel out. And then we're going to have y is square root of 3x plus 1 over 2x plus 2. And since x is 3, we were given that because we were supposed to solve where x is actually equal to 3. Then we can substitute it there and we end up having our final answer as root 10 over 8, which can simplify to root 5 over 2. You'll be tested question to do with numerical solutions, and here we are told the equation of a curve is y equals to x over cos squared x, for x is greater than or equal to 0, less than a half pi. At the point where x equals to a, the tangent of the curve has a gradient equal to 12. We are supposed to show that a equals to cos inverse cube root of cos a plus 2a sine theta, sine a rather, over 2. So it means that in order to approach this question, what we're going to do, we are going to differentiate this equation that we have here, y equals to x over cos squared x. We're going to differentiate this and then equate it to 12. And then we're going to make a the subject of the formula. So to do that, we need to decide, because these are two functions divided, therefore we're going to use quotient rule. So we're going to decide which one is going to be our u and which one is going to be our x. Remember, quotient rule states dx du dx d of dx u over x, d of dx u over v is going to be equal to v du dx minus u dv dx over v squared. So in order to work out this, first we need to find what's our du dx, and we find dv dx. Remember, du dx, u is x, so du dx is 1. Our v is cos squared x. So meaning dv dx, we are going to take this power down. So it's going to be, in order to differentiate this trigonometric function, we're going to take the 2 down so that we decrease the power by 1. So it's going to be 2 cos raised to power 1 x. Then again, now differentiate the cosine x without looking at the power. So this is going to be negative sine x. So we end up having negative 2 sine x cos x as dv dx. Then in order to find the y dx, we are going to substitute this to the quotient rule, and we end up having cos squared, because our it's v du dx and our du is 1. So the v was cos squared x time. So this is going to be cos squared x plus 1. Then minus u, our u is actually x, times dv dx, and dv dx we had gotten it here. So we are going to have this v squared. So this is cos squared x squared. This is going to be cos power 4. So we end up having that, and I decided to factor cos out in the numerator denominator so that it can be able to cancel out. We end up remaining with cos cubed x, which becomes, but we were told that x equals to a and dy dx equals to 12. So I substituted them into here and then decided to multiply. Yeah, we have this bit at this point. I decided to multiply both sides by cos cubed a. Yeah, we are going to have 12 cos cubed a equals to cos a plus 2a sine a divided by 12 both sides. We are going to have this, and then we find cube root, because there's this cube here. Finding cube root both sides, we are going to have this, which means that we shall remain with cos a equals to cube root of cos a plus 2a sine a over 12. And to get a, we are going to find the cos inverse both sides. In order to find a, we find cos inverse, and it's going to be whatever we were told to show. So basically that's what you are supposed to do. And then moving to the next part, verify by calculation that a lies between the 2.0.9 and 1. So which means that I'm going to use sign of change formula, and from this I'm going to form an equation. I'm going to form an equation from here. So since we were told this is this, we can be able to form a function. I can take this, all of this function, this other side, and I form a function of a. Let me show you how it looks like. So f of a equals to a minus cos inverse cube root of cos a plus 2a sine a over 12. And then we are going to substitute now 0.9 and 0.1 into the function of a, f of a, so that we can be able to see if there's a sign change. So if I substitute 0.9, I'm getting 0.08459, which means f of 0.9 is less than 0. And if I put 1 into f of a, I'm going to get positive 0.0358, which means f of 1 is greater than 0. So since there is a sign change and this function is continuous, it means that a lies between the two values. So given those kind of questions, remember using sign change, you can be able to get the solution. Also, there is another method you can use, using the inequality. If you using the change of inequality sign also can give you the desired results in order to verify this. Use the iterative formula based in the equation in part A to determine the correct two decimal places if the result of each iteration to 4 decimal places. So the formula that we are talking about is this formula: a equals to cos inverse cube root of cos a plus 2a sine a over 12. So we are going to form an iterative formula, and this is going to be, if you are finding a, n plus 1 is going to be this. So inside here, we're going to have cos an plus 2an sine an over 12. So what's the initial value of a? The initial value of a, we're going to get it from the average between 0.9 and 1. You can use any value between 0.9 and 1, but for simplicity, I decided to add the two and find the average. This is the best one that you can use. It will enable you arrive to the answer very fast. So when we are finding, now this becomes our A0. So to find A1, we are going to say is cos inverse of cos A0 plus 2A0 sine A0 over 12. And now substituting this, we're going to get 0.9743. The next one, now this result that we've gotten here, we are going to substitute inside in order to get A2. So upon doing that, we're going to get 0.9694. This result that we are getting here, for us to find A3, we're going to put it inside here, and I'm getting 0.9704. And this is enough to check, because we are giving our answer correct to 2 decimal places. We are going to check in 2 decimal places what's the answer. We're going to get 0.97. In 2 decimal places, what's the answer? 0.97. 2 decimal places, 0.97. Already we have gotten it. There's no need to proceed to the next ones. So this is going to be 0.97. Question 9. We are told let f of x be equal to this, expressed in partial fractions. And when you are having this, remember this is a repeated factor, meaning you are going to say 1 over a plus x plus 1, b x plus 1. Since it was repeated, you just first write this, and then for b now it's going to be over x plus 1 squared, this repeated one. But since this other bit is a quadratic that cannot be factorized, you are going to say that is cx plus d over x squared plus 1. So we're going to multiply both sides by x plus 1 squared into x squared plus 1. So which means that our expression is going to this, because x plus 1 is going to cancel with 1. So we're going to have x plus 1 into x squared plus 1. And this x squared is going to cancel with everything that we are having here. So we are going to remain with x squared plus 1. And the last one, we are going to have x plus 1 squared. So we can start by saying let x be equal to -1. We substitute into this, we are going to get our value of b as a half. Equating the coefficient of x, we are going to form this equation, and we label it equation 1. Equating the coefficient of x squared, we are going to get this long equation here, because if you let equating the coefficient of x squared is actually going to be 0 equals to a plus b plus 2c plus d. I believe you remember how to work out that. Equating to a coefficient of x cubed, we are going to form this equation, and we end up having a plus c is equals to 0. Now, from equation 3 and equation 1, let's look at equation 1 is a plus c is appearing here. And we have said that a plus c is 0. So meaning that if a plus c plus 2d is equals to 0, so it means then 2d is 0, then d is 0. So our d becomes 0. So using equation 2, let's see equation 2. Remember equation 2, we have already said we have gotten d is 0, so we can say a plus b plus 2c is plus d, but d is 0. So we are going to have a plus, and we have already gotten b. B is a half. So we can now form an equation and say this is a plus 2c equals to negative a half. And equation 3, we have a plus c equals to 0. So we are going to say a plus 2c equals to negative a half, a plus c equals to 0. We can now subtract the two equations. Then we're going to have 0, a cancelling out. We end up having 2 c minus c, we get c, minus a half minus 0, we get -2. So -1/2. So we are going to have c equals to negative a half. Yeah, you can see c is negative a half. But from this equation still of a plus c being equal to 0, see if c is negative a half, then it means a minus a half minus half equals to 0. Therefore, a is now equal to 1/2. So we have b equals to a half, a equals to a half, c equals to -1/2, and d equals to 0. Then now our partial fraction can be written in format. So you see, partial fraction can enable you perform binomial expansion, and also it can enable you to work out integration. So in this question, we are supposed to find the value of f of x dx, giving you answer in the form 1/a ln of b plus 1. So integrating each of them, so the only thing that you need to realize, we can be able to take this half outside the integral. We end up having the limit from 0 to 1. Integrating 1 over this is going to be ln of x plus 1. Integrating this, remember we are going to use power rule here, and actually this is reverse chain rule, because we are going to increase the power by 1 plus 1, and then that power we divide it by 2 here, and our integral now, when we integrate that, we are going to get x plus 1 raised to -1/1 here. And having this one, we're going to use u substitution. We are going to use u substitution in order to work out this. Let me just show you how we are going to go about it, because we are having x over x squared plus 1. In order to work out this, let me just work it here. X over x squared plus 1. We are integrating with respect to x. We can say let u be equal to x squared plus 1. So du is going to be 2x dx. So meaning anywhere we have dx, we can replace it 1 over 2 du. I've divided by 2, divided by 2. So this is u, so that we can now say this can be written as 1 over x squared plus 1 x dx. So you can see this expression that we got here, 1 over 2 du equals to x dx. So where we have x dx, we're going to replace with 1 over 2 du, which means that this is integral of 1 over u, 1 over 2 du, because x dx is 1 over 2 du. We can take this outside the integral, and then we shall have 1 over 2 integral of 1 over u du. So this is 1 over 2 ln of u, which means that going to become 1 over 2 ln of u. U is actually x squared plus 1. So that's why you can see now in this given point, I have a half ln of x squared plus 1, whatever that we have gotten here. But now taking this a half out is going to give us a quarter at this given point. Just let me just have this somewhere here for reference. This is for reference. Yeah. So once we do that, of course, the integral now is going to reduce to 1 over 2 ln of x plus 1, and the limit of integration from 0 to 1. Now, when you substitute 1 inside here, we're going to have 1 plus 1 is going to be 2. So it will be ln of 2 minus ln of 1, because 0 plus 1 is 1, but this ln of 1 is actually going to become 0. And we substitute here, we are going to have negative a half minus negative 1. And the last bit also is going to be 1 squared plus 1 is going to be 2 ln of 2 minus 0 squared plus 1 is actually 1. So we're going to have minus ln of 1. And this ln of 1, remember, it's 0. So this part will be 0. So we end up having a half ln of 2. And this part is going to become positive, because this is 1 minus half is going to be a half, times a half is going to be 1 over 4. And this section here, we are going to have ln 1 going to be 0. So we're going to having 1 over 4 ln of 2, and then 1 over 4 ln of 2, which is going to simplify to 1 over 4 ln of 2 plus 1 over 4. So we can take 1 over 4 out, and have, we shall remain with ln of 2 plus 1. So this is a quarter ln of 2 plus 1 is exactly what we were supposed, the form we were supposed to leave it at this given point. So we can say the objective was objective next particular question. Question number 10 is about vectors. We are told that a point A and B have position vectors 2i plus j plus k and I minus 2j plus 2k respectively. The line L has a vector equation, this, and we're supposed to find the vector equation of a line that goes through A and B. So we have the position vectors of A and the position vector of B. So meaning we can be able to find the direction vector AB. So AB is AO plus OB. So meaning that AO is negative of OA, which is going to be negative 2, 1, and 1. And that's going to become, we shall subtract now, and we shall have the direction vector to be negative 1, negative 3, positive 1. So remember, a vector equation is usually given in this form, where A is one of the fixed points. It can be n of the given points. A scalar multiplier, that is lambda times the direction vector of B. So our vector equation becomes this. We can be able to write it in column form, or we can be able to write it in unit terms of unit vectors like that. So this become our equation. Find the acute angle between the directions of A, B, and L. So the direction of A, B is, we're going to denote as direction AB, which is going to be negative 1, negative 3, 1. And the direction of L is going to be given by gotten from this particular point. So this is 1, negative 3 in column form, negative 2 in column form. So this is going to be, now in order to get the angle, we are going to say cos theta is equal to the dot product of the direction over the magnitude of the direction vectors. So remember, dot product is, you are going to multiply negative 1 times 1 plus negative 3 times negative 3 plus 1 times negative 2, and we're going to get 6. Magnitude of direction vector AB, we are going to find it as the square of negative 1 plus the square of negative 3 plus the square of 1, and that's going to be 11. The magnitude of BL is going to be 1 squared, and actually this is 1 squared plus negative 3 squared plus negative squared, which is going to 14, which means that we shall have cos theta equals 6 over root 11 times root 15, and the cos inverse to that we are going to get, correct to one decimal place, as 61.1 degrees. Now, in order to show that the lines through A and B do not intersect with line L, we are going to equate to the two equations and find the value of lambda and mu. So equating the two vectors, we are going to form the first equation, and we shall form the second equation. We try to solve these two simultaneous equations. So solving the two simultaneous equations, we get the first equation as mu equals to 1 minus lambda. So which means that we can be able to substitute it into the second equation. Yeah, so if we take 1 minus 3 lambda equals to 2 minus 3 mu, and then we substitute whatever mu that we have gotten at this particular point, we're going to get our lambda to be a third. Now, using the first equation, we can now substitute this a third. We get mu to be 2 over 3. Now, remember, for the two lines to intersect, we have to ensure that this also equation must be satisfied by the value of lambda and mu that we have obtained. So substituting them into the third equation, we are going to get that 4 over 3, in fact, is not equal to negative 13 over 3. So since the third equation is not satisfied, and these two lines are also not parallel, it means the two lines do not intersect. So we can say they are few lines. Sometimes you can be told to show that the two lines are skew or they do not. Verify that negative 1 plus root 2i is a root of this equation. So if we are told is a root, it means that this value that we are given at this particular point is actually z. So meaning we are going to substitute it inside here and check whether the answer is 0. If the answer is 0, it means that indeed is a root. So before we start substituting it, we need to find z raised to power 2 and z raised to power 4 so that we can be able to substitute. Since our z is negative 1 plus 2 root 2i, then if we square this, we are going to have negative 1 times negative 1 is going to positive 1. Negative 1 times root 2i is going to be equivalent to negative 2i, then negative positive 2 root 2i times negative 1 is going to be minus root 2i. And then if we multiply root 2i times root 2i, that's going to be negative 2, because I times I is a negative and the root 2 times root 2 is 2 positive, so the answer is going to be negative 2 at that point. So in order to get z4, we're going to say is z squared then squared, and if you expand that, you are going to get negative 7 plus 4 root 5. Now substituting all this into this equation, we're going to realize that this is going to be equal to 0, because if you substitute z4, our z4 is right there, 3 times z squared, 3 times z squared is 3 times this, becomes negative 3, becomes negative 6 root I, and then this times 2 times z becomes negative 2, 2 times root 2i becomes positive 2 root 2i, and then plus 12. If you work it out, you see they will cancel out, and the answer is so. That is what you are supposed to do to verify that. Then we are supposed to find the other roots of this equation. In order to find the other root, remember if we were told that 1 minus 1 plus root 2i is the root, then it means its complex conjugate is also a root of that. So factors are going to be, we can be able to form factors. If you equate z to this root, you take it on the other side, now you'll have a factor. And also the complex conjugate, we equate this, take it on the other side, we're going to have z minus negative 1 minus root 2i is also a factor. But if you multiply the two factors, you are going to form also a factor of the cubic function. So meaning that if we multiply this factor that we have here and this factor we have here, we are going to have a factor of the quadratic equation that we were having. So I have multiplied this and I've tried to expand everything. I ended up having x squared plus z squared plus 2z plus 3, which is a factor. So meaning if I take this factor I've gotten here, divide by the quadratic equation that we were having, we are going to use long division and you are going to get another factor. So once you have this factor, you are going to solve this as a code using, because this is actually a quadratic factor, we are going to solve it because this factor that we were having initially, this one times this one will give us this, and remember that was equated to 0, so we can say this part also can be equated to 0. Then now we solve that quadratic using a quadratic formula. So upon solving, you are going to get your solution to be plus or minus root 2i, root 3i. So meaning z, another root is 1 plus root 3i, all z minus 3i. So that's what you are supposed to do. And now this becomes three roots, the four roots of this quadratic equation. So which means quadratic equation solution.